The first question you want to work on today is how do you choose 4 objects out of 12 with replacement. So you have 12 objects. You can think of a bowl full of objects and you're going to choose 4 of them. You're not going to throw any of them back in the bowl. How many different ways are there to choose those 4 objects in order? Okay, think that through before you look at what we're going to do here. Okay, so question is 4 out of 12 without replacement. To answer this, we think of breaking the selection into steps. First step, what's the first thing that you're going to do if you're going to choose 4 objects? Well, first thing you're going to do is you're going to choose the first object. So step 1, we choose the first object. How many choices do you have for the first one chosen? Well, 12. Okay, step 2, we choose the second object. Well, there are 11 choices. Step 3, the third object, there are 10 choices, and 9 choices for the fourth object. Now, what you choose for the first object does influence what you have left to choose for the second object, but it doesn't influence the answer to how many choices there are. No matter which object you choose first, there are 11 choices for the second. And no matter which objects you chose for the first 2, there are 10 choices for the third. Obviously, which objects get chosen for the third, or from which objects you have to choose from for the third, depends on which objects you chose for the first 2, but the number of choices doesn't depend. And the number of choices for the fourth object doesn't depend on which objects were chosen for the first 3. So the number of choices at each step is not influenced by which objects were chosen previously. So the fundamental counting principle applies. And there are then 12 times 11 times 10 times 9 possible ordered choices. The next question is how many possible sets of 4 objects are there among our choices, our 12 times 11 times 10 times 9 choices for the 4 ordered choices for the 4 objects. Okay, well, a set of 4 objects is unordered. It doesn't matter in what order the elements of a set are listed. If the set has those 4 elements, no matter what the order, then that constitutes the set. Okay? So, suppose our 4 objects, and that should be plural, suppose our 4 objects are labeled A, B, C, and D. Then, in how many different orders could the objects A, B, C, and D have been chosen? Okay? And now, if the objects are A, B, C, and D, then the set is the set A, B, C, D. And in set notation, the set is written in brackets A, B, C, D. And the order, again, in which these things are listed in the set doesn't matter. The set is the collection of the objects, not an ordered collection. Okay, so in how many different orders among the 12 times 11 times 10 times 9 ordered choices of 4 objects out of 12, in how many different orders could this set A, B, C, D have been chosen? Well, we can break the ordering of these 4 objects into 4 steps. In step 1, we choose the one that's going to be first. There are 4 possible choices for the one that's chosen first. Then 3 for the one that's chosen second, 2 for the one that's chosen third, 1 for the one that's chosen fourth. And the fundamental counting principle then tells us that there are 4 times 3 times 2 times 1 equals 24 ways to order the 4 objects. So what do we have now? We have 12 times 11 times 10 times 9 ordered choices, but every set of choices could be ordered in 24 different ways. Okay? Another way to look at the ordering of any given 4 objects is to draw a tree. A, B, C, D, any of these could be chosen first. And then if A is chosen first, you can choose B, C, D second. If B is chosen first, you can choose A or C or D second, and so forth. And then if A and B are chosen for the first two, the last choice could be C or D, and these are written really small, but you know how to make this tree. Okay, this tree represents the 24 different orders in which A, B, C, and D could be chosen. Or we could do a listing, alphabetical listing. I've listed A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B, A, D, B, C, and A, D, C, B, and those are the choices with A in front. Now, there are 6 of them. There are 6 possible choices with B in front, or 6 possible orders with B in front, 6 with C, 6 with D in front. Any way you look at it, you find that there are 24 ways to choose 4 objects, A, B, C, and D. And the objects don't have to be labeled A, B, C, and D. This analysis here doesn't depend on the letters A, B, C, and D. The letters are simply there to make it possible to draw a tree or a listing. The fundamental basic idea then is that there are 24 ways to order 4 of these objects. So there are 12 times 11 times 10 times 9 ordered choices of these 4 objects from 12. Each set of 4 will appear in 4 times 2 times 3 times 1 different orders. Now the question is, how many sets, how many unordered collections of objects can be selected? How many unordered collections of 4 objects can be selected from among 12?